So let's start. Let's see what I'm going to solve today. So first question I'm going to solve it is the remaining question of the stack and queue. Right. So just this much question left behind to solve. Let's We are given the integer of array nums and the range of sub-array nums is the difference between the largest and the smallest element in the sub-array. Okay, return the sum of all the sub-array ranges of nums. Okay, so we have 1, 2, 3, 1, 2, 4, 5. One example, take one example. For this, is so 1, 1, 2, 1, 2, 4, 1, 2, 4, 3. Now 2, 2, 4, 2, 4, 2, 4, 3. Now 4, 4, 3. Now 3. That's this 0. This become 1. This become 3. This become 3. We have to find like how much this gonna contribute, like each element. So what we can do, like 1, 4. Let's try this question. How is this different? So give me 2 minutes. I will be back. Before that, you can try this question and tell me the solution of this. You have to find how many, how much this contributes. Like let's say 1, 2, 4, 3. So this is right. It's not this. What are next one? Most next. Like, here, nothing next one. It's next one. Here, next one. And next one. So I don't think it's going to work. Let's try to cut it down. We can build it using and next one. We can build it using brute force approach, right? We can solve this using brute force approach. But it is suggest that can we solve it in degree of n time complexity? That's how can we solve it? So you can go like a 1, 3, 4, 3. Contribute to this one. To find like 1, 3, 4, 3. Next next greatest element. Like there is nothing. There is nothing. There is 4. Two, and there is 1. Business. Now let's take previous greatest element. Previous element like there is nothing. There is nothing. Previous greatest element. There is nothing. Nothing. Previous greatest element. To be mentioned and this would be an. Now let's see how can we solve it. It's like how much one will be contributed. This one is a complicated answer. This is little bit complicated, right? How can we solve it using, like, if we take the subarray sum of a maximum and subarray sum of minimum, we can make the minus and the result is same. So I think that's good for the system to maximum. How many contributions this gives? Maximum कितना तो लिया ये चार 1 2 3 4 5 6 so 6 that means 3 and 2 plus 1 is 3 so it's a 9 na 2 plus 1 is 3 into 3 9 I don't think 9 6 then. I think the result is 6 now. Next greatest element we have to find like just we have to find next greatest element what will be so this will be next greatest element and that means 1 2 3 4 5 and 5 4 4 here 4 4 next greatest element is 3 next greatest element is 1 now let's see that is minus 1 minus 1 and minus 1 and next 2 now let's look at the situation and let's try to understand the Kahani. Kahani understand. Let's see how much contribution 4 give. 4 give like 2, so it's a 2 and 3, 6. 6 times. So how many 6 times? We have to find that like where is some of the ranges of the maximum. Like for like we have to find this question. Mhm. We just copy from here, whole copy, whole copy, copy, and paste it out here. Paste it out here. Just remove the mod. Sorry, just remove the mod. Right, remove the mod only. All good. Yes, just remove the mod. All good. It's give return the maximum. Now same as we have to write as minimum. Same code we have to write. We have to write same for the it gives the sub array sum of minimum, and now we have to find the sub array sum of maximums, right? So this is next the smallest element, next greatest element. Now again we have to find this much again Just remove the country. Just remove. Here take write it. It's maximum maxes. Right. So there is sum of maxes. Now we have to provide like next, not a next. Find the next greatest. Find next greatest. Okay. Now find the previous greatest. Right. Now we have to try to understand here this this all are good now. I think so. Just we have to change the sign, right? Now from the next subarray we have to find like here we have to just do greatest greatest. Here we have to do greatest. Just all good. Okay. previous previous greatest. We have to find the next greatest. Not the final version. At the final version, what you have to do? Just you have to do like long, long, long. Max is equal to max is equal to sub max of you have to call this much nums. Now long, long. Min equal to just we have to see the solution of that. What is the I think I write the code but left something written on code. Okay, here. Why this? Not introduce this now. Just we have to remove all find the maximum. Just remove left plus I plus country. Now let's greatest element. Now let's remove it. Now let's see. This should be this is right answer. What we are doing here, just we have to find the subarray with okay, so wrong answer. I think there will be a right answer, but let's see why this is wrong answer. So, this in the previous. Now I think Let's to wire on answer. Let's let me see the concept behind it. And the smallest and the smallest means of where I understand now. But it is previous minimum element. Why we have to use the previous minimum element like 1, 2, 2, 4. Previous minimum element is like 1. So not a pushback. Just 2. Just minus 1. Previous minimum. Find the previous minimum element, smallest element we have. Yeah. Okay. So this we have 0. So now let's say it's, so it's remove out. Right. Now let's see for this like in minus 1, it's minus 1. Check for the it's like 4. So it's completely root of and the completely root of and it will become minus 1. So minus 1. Now it's become 4. Now it's come to find the minimum element. So find the next minimum element by this. This element is the first one. Next, as smallest element like so it is what? Don't think. So that's it enough. Why this? Find the next smallest element. Okay. Find the next smallest element. Solve it. Now let's check for the greatest element. We have to find the greatest element, find the next greatest element, we have to find n. Now next previous greatest element should be previous for the greatest. We are just minimizing. There is an error. Let me ask for the chat GPT. Right. Chat GPT. It, amount is correct, but the problem overflow condition. Left, right. So this table done 6. Okay. So into maximum. Okay. So what is the solution? Okay. Here. Your task condition is for the minimum. Next for the maximum. So it's the previous. To avoid duplicate counting for the equal element, the row answer come below. No. Step. Not the. Okay. We have to just change the long condition, right? That's right. Let's change the condition here. Long and long. And one more time. Find maximum. Long. Oh, sorry. This here. Just we have to change this long overflow conditions and also here. This might be chosen, this might be give the right answer. Again, wrong answer. Why? Why is it printing this much? Are you printing like why? Just why you're printing? Just remove this. Just convert all in long. Just convert all in long. Long means over just give all in wrong. Wrong. This should be give the right answer, right? Think so. Let's say this should provide me right answer. So why is sorting, bro? It's not sorted. Okay. This is not sorting, but all are just I have to learn one thing, right? Just I have to learn one thing. Yes, just basically then we example have to understand this. Since summary can be counted multiple times. Okay, so next previous let's do take an example of it. Let's take this and this. How much contribution this is? This and this. Two times. How much contribution this for four times. Next smallest element. Previous smallest element. Yes, just we have to use previous element. Okay. Just we have to learn it. This question is this question. Yes, it's the next question. Okay. So let's see. Right. 2, 4, 3. Yes, greatest payment and previous greatest. Right. Next greatest payment. Next one. Next one. 4. 4. Yeah. 4. Yeah. And 4. Right. Greatest element. Next greatest element. Right. Yeah. We have business solution. Now previous greatest element should be next week. Minus 1. Right. Should be next week. And for the one business solution. For two greater minus 1. Yes. 1. We have to find the previous greatest element. Right. 1. After 6 greater than yes. Just remove it. Minus 1. Now minus 1. Okay. Answer. Now again it's come to now let's see wait. If it is okay, yeah. Now I understand. So, next greatest element. So now next greatest element. Okay. We have to see the first. Okay. See the top. Four. That's good. Now let's come after this. Right. So it's without two. I don't understand. The next greatest limit should be four now. Right. I put that. Yeah, yeah. Let's see. Next, greatest data element. Part one. Second, I code it down myself. Yeah. Now let's start for the test case, right? What test cases? What yeah. Okay. I thought myself. Good. It is the solution. Add a solution. And just move compiler. Right. Now check for the custom output. 1, 2, 2, 1, 4, 3. Let's say it's like a minus 1, 4, 4, and 2. Oh, right. This one minus 3, so something. 1, 2, 3, 4, 6, minus 1. Now again it's 4 and it's some 4. So it's removed minus 1. Now value is 4. Now let's check this greater nothing. It's not greater. So suppose again. So it's push now. Push. Yeah, it's push. Again something. Just write this. So this is the so this is something right. It's possible. Right. Okay. Let's look at this we have to do. Right. Right. And for the system, can we give you 10 more? happening? Why this? What what is the question? Yes, yes, we have. Now let's move to the next question. Right? Design algorithm that collect. Okay. So we have something like this. Let me see. Is that so? Like to take here, so we can't take here. Right. Now, if we take from the here greatest, so we can't take from the here. Right. Yes, I think this is the right answer. Yeah. Save to save. So I try to understand from diagram why we are doing like from one position we are taking equal to and remove it. So this is because of the duplicate, right? So you can either do from like let's suppose we take from here duplicate array and we have to remove from here duplicate. Now in the next scenario, let's suppose we take the here duplicate not duplicate and here allowed duplicate. This will provide the right answer, right? So or you can do either way. Like from here we can go at this and for row, here you can this, and for here you can like this, and you have to remove from this. So this is for like if you try run like for 2 and 2, you can understand why I'm doing this. So this is the problem. Now next question. So design an algorithm that collect the so design the stocks plan algorithm collect daily prices for for the sum of stocks and return the spam of the stock price of the current day. Okay, so it's collect the price daily price of sum of stock and return the spam of that price for price of that of the for the current day. Okay, so the spam of a stock price is 1 day. The spam of a stock price in 1 day is maximum number of consecutive days starting from the that day and goes backward from which the stock price is less than or equal to the price of that day. What the span of the stock price? Okay, is in 1 day is the maximum number of consecutive days starting from that day and going backward from which the stock price was less than or equal to the price of that day. For example, if the price of a stock is the last 4 days 7, 2, 1, 2, okay. And the price for the stock is 2, and the price of the stock today is 2. Then the span of the stock is 4. Then the span of the because the starting from the today, the price of stock is less than the 2. What? And then the last 4 days, no, the price of the stock today is 2, and 4 because that's from the today the price of stock is less than or equal to 2. So, and this calculate the price of the stock is just for the is given in the price of stock. Today is 8, so the time is 6. And starting from the today, the price of the stock is less than 2. So it's for 350. How? So, today को ऐड कर रहा है तो अच्छा today को ऐड कर रहा है understand now. Now let's implement that. How many times of this collect investment like first from the first date. Now again the next come 100. Now 8 okay 61 180. So less than it's again 1 now 60. So less than equal to 60. I don't think there 1 now 17. 17 so 17 to now 17 now 17 so 180 60 70. Now again we do have a but we can use using the shape or the multi-set data structure like 100 100 so it's 180 so become 50 80 so it's 1 again 16 so it's become 16 so it's 1 now let's see from the see 60 80 70 so it's find the upper bound become this. Now we have to just find side minus how many times like we can use simple stack here. Like, first come the 16 so it's a 1 now let's come this 18 so if it, it is greater than not greater than 70. Now let's come 16. Let's come the 16. Yeah, this is not. So one again. Now let's come the 17. 17. If it is less, if it is less, yeah, it is less. So it's become 2. Now not again. So it's push. Now it's 16. Now it's 16. Now let's just again come 16. So it's become this, not this. So it's become again 2. 1. It's 16. 7 to 16. That's the let's become 17. On the 17, let's and if it is 100, 80, 100, 80, 60, 70, 60, 25, 85, 85, 65, 85. Right. Now let's see. This one, then this one, then this one. Now we have to find like this two, the two, again 60, 60. Yeah. There is nothing but the good bit. It's the one, only one. You have to find it and good bit, right? And good bit. Okay. Now again 75. So we have to find it. It's, it's 4. You have to find like right? Yeah. So we have to use a stack 1 or stack 2. A stack 1, 180, 30. Now come the 60. Come 60, 1 data. Now 70. Now 70. The question is like that. How? Use here. Why? If we use the multiplex problem, like 100, then become as 60. Now it's becomes 17, so it's 17 here. Now we have to take 5 from the starting. It stands from it multi-set. Now again 60. You can use here the multi-set, right? But how can you approach using using G? It's 60. Now it's come the 70. So it's become great right now. So much to 70. Now it's again 60. Now come the 60. The 60. How to approach next? What can you use here? Example is like I can use the stack or the statement like a stack. Okay. use the stack. So become 80 again. So it's 1 data 1 and 60. So again it's come one. Now again comes to mind 17, 100, 80, 60. Now combine to the 17. 17 less than 17. Let's put where we are. Just maintain that. And then on. Let's put that. Now we can do that. Let's put third. Again. 51, 60, 51, 60 after 1, 17 is practical. We have walk of 10 is half on the text. No, it's practical. Now let's let me solve this. State first stack there in pending 60. So that's it. It would take that span, that span is equal to 1 while while it was not entity and then we got of first that's further price just span plus HP dot top top second and we dot top now that's the push push what can push price price and span and return span. Repeat the question. Let's try to solve first this one, right? I will come back. Try to read this one. Understand? Let's see that it let's say okay. I think this we did right. Yeah. Let's yeah. Question says you have to design the data structure that constrain the LRU. Okay, least recently used. So capacity you have to positive size and it's like okay. And return the key value if exists, otherwise return zero. Okay. And key value update the value if exists, otherwise it return now. If the number key exceed the capacity, so we can use here this. I think this is the problem created to stack. I don't think can I use here map like map how it is map. So size with two one is to one. Okay, one is to one. Okay, one is to one. Now two is to two. Second is two is to two. Now let's first one is to one and one is to two. Okay. Now get it value one. So return one. Three is to three. So we have to list recently. We have to eliminate from what? We have to eliminate from what? Can I use the from? You have to eliminate one. Okay. Can I use Q here? Q. Yeah. Because you say like one plus one, two is equal to two. Just we have to finding the value of Q. We can use the map also. Yeah. Right. Okay. Okay. Yeah. 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 You can use the map and Q. So it's become capacity. We have to decrease. So we have to eliminate from the from the yeah, three. So the key was two, three. Key was two, minus one, not from. So why I understand what that. Put update the value of key if we share yes. Otherwise, give fair to test with the number of pairs in the test. So that is every list recently. Okay, list recently used. Take like one comma one, two comma two. Now return get the value of one. So this return the value of return of one. This so let's return the value. So the it is used. So it is used now. Then we have to put the LRU. So it is used. One is used. And is the fourth source. It's increase. Now we have to see the how it is used or not used. It means a bit complicated question. Like what can you use here? Like a city I understand, here I understand. Why? Why this not I understand this two question are because I solved all question. This is very easy question. That's why I'm not because it's a you have to just find the area like you have to solve just rain tapping rainwater solution, right? You have to just this you have to just to solve this tapping rainwater solution or right maximum area that is like this, and you have to just column by column adding column wise like first this column, second this one by adding one if in continuous manner. So this now second is 3, it's 2 1 and 3. Now third in 4 4 0 0 3 0. So you have to just maximize the area and that's that's it this problem. So I solved this problem fully. I now I solved this one. Yeah, tomorrow for tomorrow like this is using only DQ. I solved it tomorrow. It's a DQ problem. You can use the other approach. Okay, like a sliding window or this, but I use sliding window with a DQ. Now for this stock spam, I just solve it. And for the celebrity problem, this is a big easy problem. I solved it. Okay. Now we have to problem this and this. So I can solve it for the tomorrow. Right. Now let's see for the problem today POTT problem. So it's a count the number of a special character one. You are given the string of word as okay, a letter is called a special if it appear both in lower letter and upper letter. So good. So what we have to do? Just you have to make upper 26 0 and lower 26 0. Let's suppose for photo x word. Now, if x is greater than equal to a and then x less than equal to z, so now we have to pick like upper x minus a, upper x minus a plus plus else else sorry lower else upper x minus a plus plus. Now for each, just take here cnt 0 0 26 plus plus if 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 the upper upper I greater than 0 and lower I greater than 0 and add cn sorry upper I equal to lower I then c and d plus plus. Now just we have to return the c and d. This much I think this can pass. No, why? Okay. Hmm. So it's like a maximum of upper I and lower I. Right. N not why? Okay. Not at all, just both are present. Then we have to C and T. Just we have to add C and T. Right. Now this will provide right answer. If I solve now from tomorrow, I'm going to start the problem of array. Okay. So going to solve this problem. So it's all the IEG problem. So take it's a 40 problem. So it's going to take I think 2 days. Yeah, max to max 3 days to solve this. Just we have solved this. Now we have solved this, and we have solved the stack and queue. Also we have solved the sliding window. Now we have to just solve the heap predict algorithm or the binary tree. Okay, we just and the graph problem because we have already solved the DP problem. So just these are problem. I think in the 10th July we are able to finish all these problems. Right? We just left it behind this, and this is the hard problem of string. Right? As the function KMP, LPS, shortest spelling wrong, longest prefix. I think I solved some of problem here, like longest happy prefix. I don't think this is not solved. Yeah, but I think this I solved. I'm the first reference. Yeah, I solved this using the KMPS. Same using the KMPS LPS algorithm KMP. Right. This is the LPS. Yeah, I solved this problem in the LPS. So so that's it for the today. Uh, let's solve for the next two questions. How can we approach? Like if we take here Q, so first one to one to three, and take a 1 2. Now let's it's the one. I solved this problem using what? I'm using map another list iterator. This is like no, I solved this problem using this is my solution. DQ, yeah, DQ. I have list problem, right? Right here, list here. Yeah, it took the LRU. You have to understand the LRU concept. Let's see. That is what LRU doing. LRU list on pages that computer to manage that can solve that and then okay, just we have to remove from the here, here, we have one and one. The one and one, remove it. Again, come here. Now complexity. So using the DQ solution, I think this is the TLE, right? What we can use like certain approach. Can we use the map? The finding become easy, but the question arises like how map? Another map, the map here. Yes, this much. That's what I'm trying to do here, like using DQ here in and in DQ, right? And in cap cap so cap dot is dot cap is equal to capacity. It is finding the q, so we have to find the x is equal to x is equal to x is equal to q dot begin dq dot begin and x is not equal to q dot end, right? DQ dot, sorry, X dot plus plus. Let's start. If X dot first is equal to X, hmm, arrow key, then we have to just what we can do here. If the key is present, so we have to just eliminate that key. We have to just eliminate the key. Is greater. So if the sorry not dot, if the key dot first is itna, what we have to do? Like we have to do like a key dot erase X and just break now. Just break, not a break. Q dot pop back. Push back. X. D. And you have to find like second. And with the X dot second. Now we have to check like IT. So the X dot begin and IT will not DQ now. Become DQ dot empty 9. DQ dot empty. No, nothing. Indent. And IT. IT plus plus. Right. Now just we have to check like if the IT first is equal to key, just we have to return DQ dot erase IT. Yeah, right. Because of current. Okay. Now we have to earlier DQ, DQ, DQ. Diffuse. Wrong answer. Why wrong answer? I don't think so. P value. If x dot second, return x dot second is that. Is written out from the ChatGPT. Why this giving the wrong answer? Okay, okay, okay. Now I understand. So you are saying that here x is erased. So it's take like let's take x x comma second, right? And you are saying that we erasing. So we are taking the value and just take here the value. This is the TLE, right? So this is the circuit of right? So I'm going to solve this yesterday, right? Okay. Thank you. Thank you for watching.